Hi, good morning. It's Mr. LaFountain here. I just want to do a quick lesson on the four types of chemical redox reactions. So we're going to learn four types of chemical redox reactions, and we're also going to have one more chemical reaction that we're going to learn to identify called a double replacement reaction. So these reaction types here, we have single, combination, or synthesis reactions. They can go by two names there: decomposition or combustion reactions. We can also see sometimes single replacement may also be called a single displacement reaction. And then over here, we're also going to learn to identify double replacement reactions, sometimes called double displacement reactions. All right, so when we talk about redox reactions, we're talking about a reaction that involves a transfer of electrons between two species. So an oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. So what this means is that an element at some point in time needs to change its oxidation number or its charge. Charge is going to be pretty much the same thing as our oxidation number. So if something is by itself, it's going to have no charge, but if it's combined with something, it will have a charge. So we're going to be we'll be doing that in a later lesson, talking about identifying who is being oxidized, who's being reduced. Today, we're just looking at identifying the types of chemical reactions. So if you're on my website here, there are, I put some videos on here. There's some articles. There's a slide here. And I'm just going to go through some of this information here. The videos, if you want to go on those on your own or go through some of the reading on these websites, you can. They are there for you, or if you want to watch my video here. So first type of reaction I'm going to talk about is synthesis reactions. So synthesis reactions here, we see a similar pattern here. So here's a whole bunch of them, 14 synthesis reactions. They all follow the same pattern. Two things are going to become one thing. All right. It follows this general equation type here, A plus B, and they combine to form one single compound. All right. Synthesis reactions can also be called combination reactions. All right. So let's go ahead. Let's take a look at the next type of equation here. We're going to learn about decomposition reactions. So decomposition reactions are going to follow, here's some examples here. They're going to follow all this pattern here, where we take one thing and we're going to combine these, or we're going to take this one thing here is going to break apart, right? We have the arrow here, so this is before the reaction takes place. After the reaction takes place, this one thing is going to break apart into two things, all right? So synthesis or combination reactions are kind of the opposite of decomposition reactions. In synthesis, two things become one thing, and in decomposition, one thing breaks down into two things, right? It decomposes into two things. So decompose means to break apart. Synthesis or combination means to put together. All right, single replacement reaction. So what's going to happen is exactly what it says here. We're going to replace a single element. So one element is going to be replaced. So we can see here that nickel this equation is replacing the silver. So we see over here, nickel is now in the compound and silver is by itself. So one thing comes in and then replaces the other. Same thing here. The chlorine in here comes in and replaces the bromine. Now the bromine is by itself and the chlorine is in the compound. We also have combustion reactions. So combustion reactions are anything that has to do with a flame or fire. So in a combustion reaction, we're going to find the similar pattern here. We're going to have some kind of hydrocarbon, which is some kind of compound that's only made of carbons and hydrogens, is going to react with oxygen on this side here. And then on the other side of the equation, we're going to see that the products will always be carbon dioxide and water. And that's going to be true for each reaction. So I will always see these three compounds in a combustion reaction plus some type of hydrocarbon. All right, and these can be in different numbers here, different ratios of carbon to hydrogen, but these are going to be the same over here. on the right side, to the right of that hydrocarbon. I'm always going to have oxygen in the reactants with it, and then it's always going to make carbon dioxide and water. Double replacement reactions. So these are not redox reactions because there is no change in charges. So what's going to happen here in single replacement or in the other ones, there's always some kind of element that's lonely or it's breaking apart. In this case here, there is no change in charge because all the elements remain in compounds. They never, they're not going to change their charges here or go to zero at any point. So, for example, aluminum has a +3 charge when it's in a compound, and it's never by itself in here. So it's always going to keep that +3 charge. It will never go to zero. All right. So let's take a look here. So we can see here that the aluminum is with iodine on this side, and over on this side, the aluminum is with chlorine. So it's switched places here. The aluminum has switched places with the Hg or the mercury, and the mercury is now with the iodine. So now it's over here with the iodine. So in this case here, we're switching partners. So we are flipping spots here. And this reaction, keep in mind, is the only one that we're going to learn about today. It's not a redox reaction, but we still need to learn how to identify it. All right, we're going to learn more about double replacement reactions when we talk in the unit called solubility. All right. Once you have, you've explored through the resources, you've watched my video if you would like to. I'm going to stick around here and work on this worksheet for a moment. You want to make sure you do the assignment in Skyward. This worksheet here is just for practice, and we're going to look at this together here. We're not going to balance today. We'll do that another day. Right now, we're just going to identify the reactions taking place here. So the reactions taking place here, we can see that sodium has switched with the hydrogen, and the hydrogen is now with the bromine. You can see that over here. That'll tell us that this is going to be a double replacement reaction. All right, and the same thing's going to happen here. We have calcium moving over to aluminum, aluminum switching with the calcium here. They've switched partners. Again, this is going to be another double replacement. All right, then over here, we're going to see that now this is by itself. So, but it is still doing some replacing. It's replacing the iron, and then the iron's by itself. So, whereas a double replacement, they've switched partners here. In this one here, somebody started out as a single element, and then it's taken this place here. So this is going to be a single replacement or a single displacement reaction. Right? I can use the word replacement or displacement. Depending on what you read, it may use a different word. Next reaction we have here. This is going to be quite a telling sign here that this is going to be what type of reaction it'll be. I see we have O2 and a hydrocarbon in the reactants, and in the products here we have CO2 and H2O. Whenever I see a hydrocarbon plus oxygen making CO2 and water, this is always going to be a combustion reaction. All right, we're going to scroll down a little bit here. We're going to look at these ones here. So in this case here, we see that we have, in this one here, we have one thing is going to break down into two things. So we see the arrow here. One thing breaks down into two things. If I'm breaking apart, I am decomposing. This is a decomposition reaction. Decomposition. I'm going to skip this one for now. And then number 7 here, we see two things becoming one thing. So if I'm putting it together, this is going to be a synthesis. Or depending on who you ask, they also might call this a combination reaction. So this is the same thing, a synthesis or combination reaction. All right, you can call it either one. You might see it either way. Why I skipped number 6 is we already did a single replacement one. I just wanted to show you the different compare a decomposition with a synthesis reaction, show how they kind of are opposites, where if I have one thing breaking into two, that's decomposition. And if I have two things breaking it, or two things turning into one and combining, I have a synthesis or a combination reaction. All right. So you have an assignment today, 6.3 in Skyward. So make sure you do that. That's going to be for the grade today. Remember, this worksheet's not due. This is just practice. So is the quizzes game that's listed, and the other worksheet in Skyward. So let's see, there we go. We're scrolling up finally. The quizzes is going to have the same title as this, as the objective here, 6.3, the 4 types of chemical redox reactions. That's your Skyward assignment for today. Make sure you do the warm-up so that I can mark you to help me keep track of attendance. Please do the warm-up question. If you have any questions, please, you can, if you're outside of class, please email me. If you message on Google Classroom, I may not catch it right away because it may get lost in my emails, because I get a lot of Google Classroom emails. But if you email me specifically, that'll go straight to my main email box, not my Google Classroom email box, and I'll more likely see it and catch it faster than if you message me or just comment in Google Classroom. So if you have any questions, please just use my email versus commenting in Google Classroom. I might miss it if you put it there. All right. Have a great day. Close this.